All right, so last time we were talking about loops. Here's a code example from the textbook. Wouldn't work. There's no colon there. But if we corrected that typo, what it does is it sets three variables: number, exponent, and product. Well, the product has to be set to 1 because what it's doing is it's calculating 1 times 2 times 3 times 4 times whatever. And if you started with 0, well, 0 times 1 times 2. 0 times anything is 0. And I really don't like the the variable each pass, but that seems to be their favorite. So for every number in the range of the exponent, so if you type in exponent of 10, it's going to count 0 through 9. Because that's the way the for statement works. Is it starts at 0 and it goes up to, but not including that value. If you leave off the first number before the comma, then it just starts at 0 anyways. And they make the note here that if the exponent were 0, then the loop body would not execute. Right? Because you can't start at 0 and end before you get to 0. So it would just skip all of that. So a loop to count through a range of numbers. Here's a more traditional loop. For count in range 4, well, that's going to do 0, 1, 2, and 3. And so it's calculating 0 times 1. Well, it's calculating 1 times 2 times 3 times 4, which is 24. If you specify a lower bound, it starts counting at that. So this would count 1, 2, 3, and 4. Start at 1, end before you get to 5. So the assignment operator can be combined with arithmetic operators to provide what are known as augmented assignment operators. Other languages call them compound assignment operators, like plus equals. A plus equals 3 is the same as A equals A plus 3. A star equals 3 is the same as A equals A star 3. And so on. S plus equals there is the same as S equals S plus there. So we're assuming that S is a string at this point. So off by 1 errors. Off by 1 is when you mistake where it's going to count. We think this is going to count from 1 to 4, but it really only is going to count 1 to 3, just because of the syntax of the range statement. That number has to be 1 past where you want it to stop. Not a syntax error, but a logic error. Right? We just put the wrong thing in, so it did the wrong thing.
What if you added 0 in the beginning, so then 0 through 4? Would that
Well, you mean like that or like that?
Like that.
Yeah, it'll count 0, 1, 2, and 3. It will do 4, but it's not going to start at 1 and count 2, 4. It's going to start at 0 and go to 3. 0, 1, 2, and 3. That is 4 numbers. That's the same thing as just doing that. Start at 0 and go up to and not including 4. So 0, 1, 2, and 3.
So you end up needing to put 1 through 5.
Yeah, if you wanted it to go 1 to 4, exactly. That's how you make it get up to 5. If you want to go 1 to 4, you make it 1 comma 5. So it'll go 1, 2, 3, and 4. And then stop before it hits 5. Very good point. So traversing the contents of a data sequence. If we make a list from a range, you can do that with the list function, which is kind of like the float function or the int function. It takes whatever's inside it and converts it into a list. We may as well play with idle and look at that. I'm just going to stay in the shell for a moment, not even go into the programming mode. If I type in this, L equals list subscript, range subscript, 1 comma 5. Why am I saying subscript when I mean parentheses? List parentheses, range parentheses, 1 comma 5, close parentheses, and then I print L. Just type in L and hit enter. Then we see it's equal to 1, 2, 3, and 4. So L is a list. It's a series of data elements. In some languages, you might think of it as an array. It's not an array, but it's pretty close to being one. The only difference between a list and an array is that you can add things to a list and you cannot to an array. If we wanted to add a number to that list, we could do so. We could type in l.append and type in the number that we want to append to that list. Like I'm going to append a 10 to it. And then when I print it out, it'll say 1, 2, 3, 4, and 10. We have appended to it. So lists will resize to hold the amount of data that they need, whereas arrays are fixed in length. Once you declare an array, it can't be appended into. So strings are also considered a sequence of characters. So if we do this, s equals quote hello end quote. Oh, let's go ahead and do it in a program. File, new, I think we're on H. Name equals Vader end quote. And then for ch space in space name colon print parentheses ch in parentheses, and it's going to print out VADER. Just like a range statement, except now it's using this series of values here. So a string is essentially a list of characters. How about nums equals square brace, quote, 1, end quote, comma, you don't have to put that many spaces in it, quote, 2, end quote, comma, quote, 3, end quote, closing square brace. And then for value in nums, colon, print parentheses value. And it's just going to print 1, 2, and 3, 1 per line. Yeah, 1, 2, 3. Yes, sir.
So I know you went through this. I just wanted like a quick refresher because I don't quite understand.
Yeah.
I'm understanding what nums mean. You know, you declared that and you put it in the brackets, so you know everything in there is what nums is. But where is it getting value from? Or like, you know, it says for value. Like, what exactly is that again? And
what this is it's a variable name. There's nothing magical about a name. We could have called it X. But what it does is this statement says for everything that is in the nums list, first copy the first one into it, and so it prints X out. And then copy the second thing into it, and so it prints 2 out. I meant to say 1. And then copy the third thing into it, so it'll print 3. So if we have this for j in, and then we do subscript, square brace, 8, 6, 7, 5 in square brace, colon, parentheses j. J equals first 8, so it's going to print out an 8. And then the 6 gets copied into J. And then the 7 gets copied into J and printed out. And then the 5. So the same deal here. This list variable, just a second, every element in it will get copied into X one after the other. So the first time it's going to print 1, the second time it's going to print 2, and the third time it's going to print 3. Okay. And the variable name isn't magical. I called it value because it's a value in the list, but we could have called it anything. Okay. Does that make sense?
Yes.
Yeah, okay. Yes, sir.
Just for clarity from me, like in old programming languages, like Turbo Pascal, for example, you would have to define the
variables before you
use
used them.
The script, but in this, like value is defined in the for state.
Exactly. Right. We did not have to create that variable beforehand because it's being created right then and there.
Different from name. Like name is you're defining name at the very beginning.
Right. We had to create the name variable here before we could use it there. But then the for statement defined CH for us, so we could use it. And yeah, you're right. You know, in Turbo Pascal or whatever, lots of languages you have to define stuff before you can use them. But we don't have to do that. Yes, sir.
And so would this be the same as creating like a dictionary, everything inside of that after you declared it?
Well, a dictionary is a completely different data structure, but like that defines a dictionary.
Right.
And well, let's
Just curly braces.
let's do Spanish, and then we could say Spanish for red equals rojo, I think, something like that, I don't know. Spanish for 1 is uno, and so on. And then if we print out Spanish, let's print that out as opposed to printing out nums, and we'll take a look at the difference between them. Right. So Spanish is a data structure where that is corresponding to that, and that is corresponding to that. The list is a data structure where everything just corresponds with its position. That's at position 0, that's at position 1, and that's at position 2. But they're accessed very similarly, right? So if you wanted to print out rojo, you'd print out Spanish subscript red. That making sense? This is about 10 chapters beyond where we are, but yeah. So this is an example of a different data type called a dictionary. You do not have to type any of that stuff in, but if you feel like it, you can. What this says is I'm going to create something where I can link up these keys to these values. And so true enough, the Spanish word for red, rojo, the Spanish word for 1 is uno, and we can do dos and tres and, you know, and stuff like that. And so if we ever want to find out what the Spanish word for 1 is, we could do that. We could do print parentheses Spanish subscript quote 1 end quote in subscript, and it's going to print out uno. I forgot to put my end parentheses there.
So this is probably outside of the realm of this lecture, but I'm asking anyway. If you had a program that you wanted to access on a one-word concept, could you make it into a dictionary and then it runs that program? I think we talked about that.
Okay, repeat the question, please. I'm so sorry.
So if you had a program, you wanted to say, instead of writing all the other stuff, you wanted to come up and run, you can use the dictionary phrase for that program. Say you made it num, the name of the dictionary, and you type that in instead of typing in that whole line of code.
Well, what a dictionary is for, it's for display. It's for storing a sequence of data elements,
Okay.
where you have, these are known as keys, and then as values. And so you can look up elements by its keys, just like in a book, in a dictionary, you want to find out, you know, and so you turn to whatever page and you find that specific key, and it's got the definition for it. And so this is the key word, and that's the definition for it. So if you want to, okay, we did talk about this. You could start your list at a number other than 0 by specifying it, and you can also make it skip by odd values other than just 1. If you leave that comma 1 off, it counts up by 1. 1, 2, 3, 4, 5. If you put the 1 on there, it counts by 1s. 1, 2, 3, 4, 5. But if you change it to 2, it's going to print 1, 3, and 5. It's still going to stop before it gets to 6, but it's adding 2 every time. And so if we change that last number to 3, it tries to count by 3s. And so it prints 1, 4. It would print 7 and 10 and so on, but it was told to stop before it reached 6. Or you can count down, starting at 10, stopping before you get to 0, going by negative 1s, then it'll print 109876544321. So formatting text for output. Sometimes we want to format things so that they're all lined up nice and neatly on the screen. Print function begins printing on the first available column. So if we're printing out numbers and then we're printing out the exponent, 10 to the power of that number, it looks like this. We might be able to make some prettier output if we care by using the formatting string. And we did just a little bit of this in order to force something to be printed out to 2 decimal places. But let's play with that a little bit more. We're going to make a loop that prints out some values, and then their squares, and then their cubes, like 2 to the power of 2, 3 to the power of 2, and so on. So let's go and modify our code so that we have a for loop going on. Go away. And we're going to print out the results with a formatted print print statement. Get lost. There we go. Okay. So we want our number to count from 1 to 10. So I'm going to do for x in range, starting at 1, keep going up to but not including 11, increasing by 1 each time. And I could leave that third comma 1 off, and it would still count it by 1s. And so then I'm going to print x, comma, x to the power of 2, and then 2 to the power of x in parentheses. And we don't really care what that means, but these are our results. And they're not lined up. Right? It'd be much prettier if each one was lined up to be a certain size. If we said, okay, the first one we want to occupy 4 spaces, the second one we want to occupy 4 spaces, and the third one we want to occupy 4 spaces. We can use those percent placeholders. I'm just going to push this out to the side for now because I know I'm going to need it. I'm going to come over here and right after this parentheses, quote %4d space %4d space %4d end quote %, and then that stuff between the parentheses that we had originally, parentheses x comma x star star 2 comma 2 star star x. And then since we have 2 opening parentheses, we're going to need 2 closing parentheses, and right now we only have 1. So 2 closing parentheses. And there we go. There's our output. Looking a lot prettier. So that's using formatted output. The placeholder, if you specify a D there, it's expecting whole numbers. If you specify an F there, it's expecting a float. If you say it's a float, you can specify how many decimal places you want. Now let's do another for loop, except this time we're going to use float. We're going to print out the value of 1 over 1, 1 over 2, 1 over 3, 1 over 4, and so on, to like 4 decimal places maybe. So for x in range, 1 comma 10 in parentheses colon. We're going to print x comma and then 1 over x in parentheses. And there we go. Sure could look a lot better. Like maybe I want them each to like 4 decimal places. 0.3333, 0.1666, you know, whatever. Well, we can do that. But again, we're going to need a formatted print string with placeholders. So I'm going to push that over like I did before. I'm going to make this say print, parentheses, quote, %. I only made this one go up to 10 for some reason. I actually wanted to count 1 through 10, so what should I put here? 11. All right. So we want the first number to occupy 2 spaces, %2d. And it's a whole number, so I'm going to go ahead and use d for integer. But the next one is got decimal places in it, so it needs to be a float. And so we're going to say %.4f, %.4f, and then an end quote, followed by the percent sign. And then our original stuff, the parentheses x comma 1 over x in parentheses. And then one final closing parentheses to wrap everything up. There. Here we go. And that looks a bit nicer than it did before, right? 1 over 9 is 0.111. 1 over 6 is 0.1667, and so on. If you want more decimal places, great. Change that 4 to something else. Want to display it out to 8 decimal places? We can do that. Make it %.8f. And there we go. So placeholders, formats, you can have %d, you can have %f. %4d means pad the output to 4 spaces. So like if it's 2, it's going to have, like if it's just the number 2, it's going to have space, space, space 2. But if it's the number 20 and it needs to fill 4 spaces, it's going to be space, space, 20. And if it's 200, it's going to be space, 200. And if it's 2000, not going to be any extra spaces added to it at all. So %.2f means display to 2 decimal places. Display 2 decimal places of a float. So %d is for ints, integers. %f is for floats. And they tacked on a third one, %s, like %10s. Pad the string out to 10 spaces. When might you want to pad the strings out? I wish I'd spelled that correctly. String. Well, if they're not all of the same length, right? Colors. Colors equals square brace red end quote comma quote orange end quote comma quote yellow end quote comma quote blue end quote. That's enough, right? If we want them to all line up, we could use a formatted prints. So for value in colors, remember the variable name is not important. I could just say V or X or whatever, as long as I use that inside the loop itself. For value in colors, print, and let's pad it out. What's the maximum width of these? Looks like the longest one is 6. So in here I'm going to put quote %6s end quote %, parentheses, open parentheses, value, close parentheses, and then another close parentheses. Just because every open's got to have a close to match. And now they're all padded out to the same length, right? And they're also right justified. If you want them to be left justified, you can use a minus sign. What if we wanted these numbers to be so-called left justified rather than right justified? What if we wanted them lined up on the left margin? We could do that. We could come up here, and where it says %4d, you could make them say %-4d, %-4d, %-, and the minus means line it up on the left side, not the right. Like that. And now you see they're lined up on the left side. I actually think I kind of like the way it looked when it was lined up on the right side, so I may take that out. But these words look kind of silly lined up on the right side. So we might want to limit them. We might want to push them to the left side. So I'm going to take those hyphens out because I like them being on the right margins. But down here, I might kind of like them being on the left margin. And now they're lined up like that. And we can't really see that each one is 6 spaces wide, but they are. And so if we printed anything after it, just a second, then we'd see it there. Like if we went here and put a comma, quote, is a great color, end quote. Normally I wouldn't do it that way. I may wind up deleting it. But what we're going to see is that they're all spaced out to the same length, right? Red is a great color, orange is a great color, yellow is a great color, blue is a great color. Now you wouldn't normally do it like that, but if you're printing out a list of first names and last names, right, you might want everything lined up in columns. Yes, sir?
Oh, so I was just wondering, so if you put %4D, that means that you couldn't print a number like 10,000 because it's 5 characters long?
Yeah, that's a very good point. What happened if the number gets too large to fit? Excellent point. What if we narrowed this down? I'm going to take the minus sign off of here. Or maybe I'll leave it on, it doesn't matter, but I'm going to change it to pretend that 4 is the maximum width. Right. We know it's not really. That one's got like 5 characters in it, and that one's got 6. But we're telling it fit it in 4. It tried, but it was too large, right? And so it just pushed everything 4. When you have that %4, that means pad it out to at least that many spaces. But if it's too long to fit in it, too bad. It can't do anything about it, and so it's going to print longer than that.
Oh, okay.
Yeah, so that's a real good point. Change that back to 6, though. Maybe take the minus sign off if I like it being justified on the right. Whichever you like. You want those lined up on the left margin, put the hyphen in. If you want them lined up on the right, take the hyphen out. Yes, sir?
What if you had a list that had it was just a really huge list, and you didn't know what the longest word or number or whatever was in there? Is there a way to use a variable to determine that and then put that after the % sign?
Oh, that is an incredibly good question, and I'm not sure how to do that. It's possible, and I can't think of an easy way to do it. It'd take me a minute or two to write it up, and it wouldn't make a lot of sense. If you're really curious about it, then we could stay after a few minutes and figure it out. But the problem for that, the question is, what if we did not know in advance what the widest one was? How would we calculate that? Well, we could step through each item, getting the length of it, but then how would we get that number into there? Well, we can create a string, a formatting string, like this. Just F for formatting string equals, quote, %6s, end quote. And then we could print out something using that. Print, parentheses, F %, parentheses, in parentheses, in parentheses, and then whatever we were going to fill in there. Purple. In quote, like that. And then purple will be formatted to be 6 characters wide, but instead of 6 we would put the number that we had calculated to be the widest element. So that would get us, that's pretty close to being an example of what you asked for, but it's a little bit obscure. What we're doing here is we're creating the formatting string beforehand, and then we're filling it in there rather than just putting it right there. That's a totally valid way of doing it. Don't usually necessarily see people do it that way, but it's a totally valid way of doing it. And then you could have gone to the list beforehand and prepared it so that this 6 was replaced with the actual length that it needed to be. So percent, and then the number before the decimal point is how wide you want it to be, and the number after the decimal place, the point is the precision, the number of places after the decimal. So here they do %.2f, they tacked on a 0, that's not necessary. %.2f would display it out to 2 decimal places. If you said %.2f, %10.2f, then it would pad it out to 10 spaces total, and one of them would be dedicated to the decimal, and then 2 more would to the point, and then 2 more would be to the place after it. So going back to our formatting, %x.yf, x is the width, and y is the precision, number of decimal places. If it's a string, you don't have number of decimal places, so for a string it'd just be %x s, where x is the width. Has to be a number, right? 1, 2, 3, 4, 20, whatever you want the width of it to be. And if it's an integer, same business. There's no decimal places on an integer, so %x d, again, x is the width. And in all 3 of those above cases, replace x with the number you need. Example, %10d, %6.1f, that kind of thing. Well, I said 6, but I typed in 5. So this would make a field that's 5 spaces wide, and it's going to have a decimal point with 1 decimal place. And so since we have 5 total, what is that going to look like? It would look like this, right? Because that's 5. 1, 2, 3, 4, 5. That's what the result would look like if we use %5.1. If you wanted to have 5 places before the decimal point, you either don't specify that at all, or you make it wide enough to count. This is 1, 2, 3, 4, 5, 6, 7. So you better make that %7.1f to get it to look like that. I'm going to pause and make sure that we don't have folks frustrated with. Scrolling back up here to our dictionary, what happens if we try to print out something that's not in the dictionary? Like we have the words red and 1, but we don't know what Spanish for 2 is. So if I put that in there and run it, it's going to generate a runtime error. It's going to say key error. Key error means that this word is not in its dictionary. You can check to see if something is in a dictionary. Again, that's beyond where we are now, so I'm not going to spend any more time in correcting that, and I'm going to change it back to a 1. But I did want you to be alert to the idea that once you fill this thing up with data, if you're going to try to access any of them, then they'd better be there. And so if you have a typo, like you try to print the Spanish version of on, again, it's going to generate an error. So a selection statement, if and if else. We have several different comparison operators. Same things we've known about since elementary school, whether things are equal to each other, or less than, or greater than. Now, in elementary school, we may have used that to mean not equal to. No, we don't have that. We do have that, though. That means not equal to. So you just don't have the, whoopsie. If you need to make it not equal to, you don't make it less than, greater than. You use the exclamation mark and then the equal sign. The exclamation mark, you can call it not equal. And we've been using if statements for a while already. Import math. Area equals float, input, enter the area. If the area is greater than 0, we calculate the radius. I like that, maths area. That's funny. What do you think that was supposed to be?
Math. I don't even know.
What?
Math is. Maybe.
Is it trying to calculate this? Because it's pi r squared. Square root? Yeah, it's trying to calculate the radius. How do you get the radius from the area?
What is the square root of the area divided by pi?
Yeah, it's the square root of area divided by pi. So this is supposed to be math.sqrt. Area divided by pi, and that would give us the radius. So the general syntax is if followed by the expression. Expression will have an equal sign or less than or greater or something that resolves to true or false, right? Area can be either greater than 0, in which case it's true, and if that's not true, then it's a false. This if expression doesn't just have to be math, but quite often it will be. What do I mean it doesn't just have to be math? If we go back to our code, remember way back up there we had a name, Vader. If, parentheses, quote, capital V, end quote, space, in, space, name, colon, parentheses, quote, the name contains a V, end quote, in parentheses. Right, so that just checks name to see if there's a capital V in it. And there is, since I've made mine Vader. If yours isn't, it's not going to do that. So it says the name contains a V. But if beforehand I'd said it's something else, like name is equal to, Tony, I'm not going to get that message. So maybe I ought to put an else on there. You can put as many statements as you want, right, like that. And then when you finally are done with your indentation, that's where your else is going to go. Now we don't need all that, obviously, but else, colon, print, parentheses, quote, the name does not contain a V, in parentheses, end quote, in parentheses. And true enough, the name does not contain a V because I changed it to Tony. If I made it Vinny, with a capital V, yeah, it's going to print that it contains a V. Since we have a list called colors, we could check to see if one of these colors is in the list. How about silver? If, quote, silver, end quote, space, in, space, colors, colon, parentheses, quote, silver is in the colors list, end quote, in parentheses. Else, colon, print, silver is not in the colors list, end quote, in parentheses. And in this case, it's going to say silver is not in the colors list because, sure enough, I did not define it to be that way. If I wanted to see silver show up, I could change one of those colors to silver and then it would work. Right, I could change blue to silver. S-I-L-V-E-R. And now it says silver is in the colors list. So the if statement doesn't just have to be an equal sign or a less than or a greater. It can be anything that will return a true or a false. And the syntax here, V in name, that returns a true or false depending on whether V was found in the name or not. This syntax, silver in colors, returns true or false based on whether silver is in the colors list or not. But more normally, we're going to probably be doing more mathy stuff, right? We might ask somebody for their age. Age equals float, parentheses, input, parentheses, quote. What is your age, question mark, space, space, greater than, end quote, in parentheses, in parentheses. And then we can do something based on it. If age less than 0, colon, print you liar, end quote, in parentheses. If age is less than 6, colon, print, parentheses, quote, time for preschool, end quote, in parentheses. If age is less than 13, colon, print, quote, time for elementary school, end quote, in parentheses. That's about it. I don't feel like doing junior high and high school and college or whatever. So else, colon, print. All done with school. Too old for school. Stupid, right? But whatever. Other languages use the keyword else if. Other languages we would have written it like that, else if. And although that doesn't look like a syntax error, it is. You know, it's not underlining anything or letting us know it's a syntax error, but if I tried to run it, it would be. So we use the word elif to mean else if. Elif means else if. What if we had not used elif in each one of these places? What if we just made it if? Watch what happens. Don't do this, but watch what happens if I delete all the L's off and just make it if. If I type in that my age is 1, what is it going to do? Well, is 1 less than 0? No, so it's not going to print you lie. But is 1 less than 6? Yes, so it's going to print preschool. Is 1 less than 13? Yes, it is. So it's also going to print time for elementary school. So it's going to print two things out when I type in 1. Time for preschool and time for elementary. They're not mutually exclusive. It does that check, great, it's all done, and then it does another check. But if we do elif, it means once one of them is true, skip to the end. So if this one's true, it doesn't check this. Instead, it comes all the way down here. So when it runs now, and if I type in, I forget what I typed in, 3. 3 is not less than 0, so it's not going to print you lie. 3 is less than 6, so it's going to print time for preschool. And then it's going to see that L, which means else if, and it's going to skip everything else. So it's not going to print time for elementary or too old for school. So if we type in 3, that's all that we're going to see. If we type in 11, that's all we're going to see. If we type in something that's greater, 13 or greater than, then we're going to see too old for school. This is a replacement for a different data structure that looks like this, and I really don't want y'all to type this. If A, do something else, colon. If B, colon, do something else, come on, else, colon. If C, colon, do something else, colon, do one more thing. Same idea. This could be if age less than 0. Please don't type this. Else if age is less than 6. Else if age is less than 13. Right. Same thing. Logically, these are the same things, but this is a lot easier to type, isn't it? Going like that would be a lot easier than typing it like that. Both would work. I mean, if these were actual print statements and not just, random letters. But that's what elif means. Else if. Else if. And so once it finds one of these to be true, it's not going to do the rest of them. If that one's true, it's going to skip the rest. If that one's true, it's going to skip the rest. If that one's true, it's going to skip the rest. Otherwise, it's going to do that one. Time to get rid of that. Or I guess I could leave it. So an if statement, this is an if-else. If something is true, then do one thing, else do another. Now if you took fundamentals with me, you're used to making the yes branch go off this side and the no branch go straight down or off the other, but it doesn't matter. So this particular book decided that the true clause is the one immediately under it. I like doing it the other way so that the true clause is off to the right because it's like tabbing, right? If something, hit the tab key, something else. This is an if statement with no else clause. So if something is true, then do it. Otherwise, don't do anything. So a program may be faced with testing conditions that entail more than 2 courses of action. So for example, grades above 89 are an A, grades between 79 and 90 are a B, grades 69 and 80 are a C, and everything else is a F. So enter the numeric grade. If the number is greater than 89, print out A. If the number is greater than 79, print out B. Or set letter to B. If the grade is greater than 69, print C. If, or just else, the letter is F. And so depending upon what they type, either that if is true, or maybe that if is true, or maybe that if is true, and if none of them are true, it gets set to F. And here we go. Now they're showing the arrows going off in the direction that I teach. If this is true, then do that one set of statements. Set your grade equal to A. Elif, go over here and set grade to B. We would have as many elifs as we need to do this. 1, 2, 3, right, and then one final else. Often a course must be taken if either of 2 conditions is true. If the number is greater than 100, we give them an error message. The grade should not be that large. If the number is less than 0, then we tell them that grade's too low. Else, and then we put the good code. They're showing that we can combine some things using the OR keyword. If the number is greater than 100, or the number is less than 0, we're going to print an error message. Let's go back and play with our code a little bit more to show using an OR. Like, let's say that the age range for a PG movie, I don't even know what that is. How old do you have to be for a PG movie? Is it 12 or older?
I have no idea.
7.
Pardon me?
I think it might be 7.
I think it's pretty low because then they do like PG-13.
Oh yeah, you're right, PG-13 and stuff like that. Okay, so anyways, we're going to, now that we know their age, we're going to check to see if their age is between 7 and 12. And if it is between 7 and 12, we're going to say that they can go into the PG movie. I don't know why we're limiting it to that, so forget it. We're not going to do that example. We're going to go back to my fallback one, which is, temperatures. So we're going to ask for a temperature. Temp equals float, parentheses, input, parentheses, quote. Yeah, so 7 and above or 6 and above is okay for PG, I guess. No, I don't know. What is the temperature? Question mark, space, greater than, end quote. And we have 2 opening parentheses, so we need 2 closed parentheses. Now we can have some if statements. If the temperature is less than 32, or the temperature is greater than 212, colon, print, water is not liquid at this temperature, period, end quote, in parentheses. So we checked outside of a range. And we said that if it's less than 32 degrees, which is the freezing point, or it's greater than 212, then it's not a liquid. So we used or to check outside of the range. Use or to check outside of a range. What about checking inside the range? We're going to see if it's between 32 and 212. Or maybe we're going to decide that our favorite temperatures are between 60 and 90 degrees. That's when it's nice to go outside. So if temperatures greater than or equal to 60 and temperature is less than or equal to 90, colon, print parentheses, quote, perfect for playing outside, end quote, in parentheses. So we used and to check within the range. So for and to work, both sides have to be true. So like we could decide hungry equals, quote, y, end quote, and money equals, quote, end quote. We are hungry, but we have no money. If hungry equals, quote, y, end quote, and money equals, quote, y, quote, colon, print, parentheses, quote, let's go out and eat, exclamation mark, end quote, in parentheses. We have to have both money and be hungry to go out and eat. If hungry equals, quote, yes, end quote, and money equals, quote, end quote, print, let's find something to eat at home, end quote, in parentheses. And maybe we should chain these with elifs so that only one of them would print. So I'm going to do that. I'm going to make this one an elif. And if neither one of them is true, then it just means we're not hungry. So print, or excuse me, else, colon, print, nah, not hungry, end quote, in parentheses. Now, depending upon the value of these variables, we'll have some of these things happen. One or the other or the third. Right now, what is it going to print? Without changing the code, if I run it, which of these 3 messages is it going to print?
Eat at home.
Well, hungry is yes, so that one's not true. And so it's going to, print, eat something at home. Exactly. So and means both sides have to be true. Or would mean one side or the other has to be true. Like sick equals, quote, y, end quote, and tired equals, quote, y, end quote. If sick equals, quote, y, end quote, or tired equals, quote, y, end quote, colon, print, stay home from school. We get to stay home whether we're sick or tired. That's pretty lax. Else, colon, print, go to school, exclamation mark, end quote, in parentheses. And so looking at it, I predict that it is going to say stay home from school because both of these are set to yes. But if we set one of them to no, it's still going to print stay home from school. What's your age? 90. Too old for school. What's the temperature? 12. Water is not liquid at this temperature. And it did say print. It did do the stay home from school. Because even though one of them was false, the other one was true. It's only when they're both false that it's going to say go to school. Because either one of them is enough to let us stay home from school because we used or. If we change this to and, we'd have to be both sick and tired to stay home from school. Because and means both sides, both expressions have to be true. And both sides have to be true, or one side or the other has to be true. So if you were going to figure out, there's something called a truth table, which if you've taken fundamentals, you've heard of before. Truth table looks like this. Just a little square with two values, A and B, and then the results. Since and means both sides have to be true, the only time the result of an and is true is when both inputs are true. If B is false but A is true, then the result is false. If A is false but B is true, the result is false. And if both of them are false, it's false, right? Because and. Both of them needed to be true. The only time an and is true is if both sides of the expression are true. Now, or, more lax. The only time it's false is when both sides are false. Every other case is true. And then finally, there's the other key word, not, which just kind of reverses the truthiness of it. If you say, if not x equals 3, it's the same as saying if x not equals 3. So we have our three logical keywords. And, or, and not. And we've seen them all except for now. If not, sick equals, quote, y, end quote, colon, print. I am glad you're not sick. Now normally I don't use not, I use not equals instead, right? If sick not equal to quote y, end quote, same business. Print, I am glad you're not sick, end quote, in parentheses. So when using equals equals or less than or greater than or whatever, I probably wouldn't use the word not. Instead, I would just write the expression the way I needed to. So instead of saying if not x less than 3, I would say if x greater than or equal to 3. That kind of thing. But remember that syntax way up there where we had if color or if silver in colors? There the not keyword is useful. If not, quote, purple, end quote, in colors, colon, print parentheses, quote, purple is not in the colors list. Now that's a good use of the not keyword. I don't see any reason to word this like this, if I could word it like this. But I don't know, if this makes more sense to you than doing it that way, go for it, right? Feel like using a not keyword to create your not equal, it's totally cool. Personal choice. So if not age greater than 17 colon print quote too young to enlist in service, end quote, in parentheses. Right? We could have worded this just as well if we had said if age is greater than or equal to 18. Which way do you like to word it? I'd rather do it the second way. It's the way my brain works. If the word not appears in your expression too often, then your brain starts to have trouble figuring out what's going to happen. The computer knows, right? But it's like in English when they talk about double negatives or triple negatives. I ain't not going to go. And you try to figure out what that means. I ain't not going to go. And you start parsing it. Okay, there's two nots in there. Does that mean I am going? Right? But anyways, so I usually try to avoid using the not keyword unless it's just real obvious. In this case, yeah, that would be the way you would want to word it. But in this case, I would not want to word it that way if I had the choice of doing it that way. Same for this. Why do it that way if you can do it that way? You can store the result of one calculation to use it later. Like, remember our temperature? Freezing equals temp less than 32. And then you can do if freezing, colon, print, brr, it's freezing. It is freezing.
Question.
Yes, sir.
Where is the, I'm typing in the if not statement where you have the variable age.
Uh-huh.
Did we define age somewhere?
We must have, because weren't we talking about it earlier? Maybe we never did. Oh, yeah, way up
Way
here.
up there? Okay.
Way up there, yeah.
So
Yeah.
I was calling on that way up there.
Right,
Got it.
right. Okay. And so boiling is equal to temperature greater than 212. If boiling, colon, print, ouch, it's boiling. And then one more, if neither one of those is true. If not, parentheses, freezing or boiling, in parentheses, quote, print, neither freezing nor boiling, end quote, in parentheses. about time to stop so we can come up with our homework and stuff.
Yeah, I got it up here on this.
Oh, okay, you just commented out.
Yeah. Thank you, though. That was very nice. Very legal.
All right. So a couple of things we're going to do. We're going to ask the user a letter grade. If they type in A, we will print that's 4.0. If they type in B, we will print 3.5, and so on. I'm going to take the word that's out, right? C equals 3.0, D equals 2.5. That's not true. Isn't a B a 3? Yeah, and a C is a 2, and a D is a 1. Else, print 0.0. So, I'm going to rewrite this just a little bit. Instead of if they type in grade, if grade equals A, we will type that. Else if grade equals, else if grade equals, and then else if. Right, you get the idea. So the other thing we're going to do is we're going to ask the user for their age and whether they are a U.S. citizen. And depending upon their age and whether they're a U.S. citizen, we're going to tell them whether they can vote or not. Now really the rules for that are pretty easy. Ask the user for their age, turn it into an int or a float. Ask the user if they are a citizen. Make them type in either yes or no. If their age is greater than or equal to 18 and they are a citizen, print you can vote. Else print you are ineligible to vote. Ineligible to vote. And then one more. We're going to, and this is a classic example from other textbooks, we're to ask somebody if they are employed and are a recent graduate. And if either one of those things is, if both of those things are true, they get the discount. So ask the user if they are employed. Ask the user if they are a recent grad, if they graduated in the last 4 years. If they are employed, which I spelled wrong, and did graduate in the past 4 years, print you qualify for the discount. Else print sorry, no discount. That makes sense? I'll write this up a little bit better. It's a little bit clumsy there. And as always, you don't have to type in the homework assignment because it will be uploaded. That making sense, guys? All right. I'm going to take the screen away so I can make the Dropbox for people. As mentioned, no class on Thursday.